And if you had to close your eyes, it is safe to open them again. We are off of our roller coaster, and we are gonna be right back in front of Mars. My friend in the front row who's got their camera on, please turn that off. Thank you. All right, so now that we've experienced Mars, we are gonna fly further out through our solar system, and we are gonna go to the planet with all the rings. Which one is that? Saturn. All right, so let's head on out to Saturn. Now, up until the beginning of March, we were actually seeing Saturn in our nighttime sky. For the moment, however, Saturn's dipped below our horizon, so we'll have to experience it this way until it comes back into our evening sky. Now, Saturn is really famous for those rings, and they are amazing. They are just about 200,000 miles from the inner edge to the outer edge, but they're very thin. They're only about the length of a football field from top to bottom. So when we view them edge on, they actually appear to disappear from Earth, which is really interesting. But we are going to take our rocket ship and we're going to get a little closer to those rings because they are so cool. Now, from a distance, these rings do look quite solid, but as we get closer to them, you're going to notice they are not solid at all. They are made of little pieces of ice and rock and dust. Now, some of this dust is as small as grains of sand on the beach, but some of the rock and ice chunks are actually as big as a one-story house. And of course, you have all sizes in between. The reason that we see Saturn's rings so well from the Earth is because of all the ice inside of them. You see, ice reflects sunlight, kind of like a really big mirror in outer space. All of our gas giant planets, so that would be Jupiter, Saturn, Uranus, and Neptune, they all have rings, but only Saturn's are really visible. We think that Saturn's rings were created when one or more of Saturn's moons got too close to the planet itself, and Saturn's gravity was able to rip them into little bitty pieces. But that is okay because Saturn has lots of moons to spare. And if we want to see how many moons Saturn has, we're actually going to have to fly our rocket ship further away from the planet to check out those moons. So we'll do that, and as we back up, we're going to add lines to our sky here. Every single line you see is the orbit of one of Saturn's moons. Now, I'm not going to try to make you count all those lines. Saturn has 274 moons. That is the planet with the most moons in the solar system. Now, you might be wondering why some of those orbits are white and why some of them are purple. There's a really good reason for that. The white ones were the ones we knew before March of 2025. The purple ones were only discovered 1 year ago, March 2025. So the purple ones, there's 128 of those up there that we didn't know about until March of last year, which is insane. We've been looking at our solar system with telescopes for a few centuries now, a few hundred years, and we had still not seen these new moons until last year. And that to me is fantastic because that tells me there is lots of stuff in our solar system that we haven't discovered yet. So if you guys are interested in being scientists one day and maybe studying the solar system, there is definitely lots for you guys to still learn. If we want to check out some of Saturn's moons, we can do that. We're going to check out Saturn's moon, Titan. This is the largest moon around Saturn, and it's going to look a little bit orange as we get closer to it. There it is. So this is Titan. Titan is actually larger than the planet Mercury, and there is something really cool that Titan has that Mercury does not. If we see this hazy stuff on the edge of Titan, that is an atmosphere. Titan is the only moon in our solar system with a thick atmosphere. Most of the moons of our solar system have no atmosphere whatsoever. So this is really, really interesting. And scientists really wanted to study it a lot further. In order to do that, they had to borrow a space trip that was already heading towards Saturn. Back in the early 2000s, we had a spaceship get to Saturn called the Cassini spacecraft. Cassini was a space mission that flew from the early 2000s until 2017, and it brought with it the Huygens space probe. Huygens was dropped through the atmosphere of Titan, and it sent back amazing pictures. We could see mountains and rivers and lakes. A lot of things that are not too unfamiliar for us here on Earth. Now, we also had a temperature reading of about negative 280 degrees. So is that liquid water? Absolutely not. We did find signs of water in the mountains, but that liquid right there, that is actually liquid methane and ethane, which is the stuff that cows fart out. So it's not really a great place for us to live. But if astronauts were to get to Saturn, Titan is definitely a place we'd want to visit for short periods of time, because we could go to the mountains of Titan and harvest some of that ice. Now, if we melt that ice, we could use it for drinking water. And if we split it into its pieces of hydrogen and oxygen, we could use the hydrogen for rocket fuel and oxygen to breathe. So Titan is definitely a place that we'd want to go. And if we're going there anyway, how about another roller coaster?
No.
Let's do another roller coaster. We're going to take a roller coaster ride on Titan. Now, Titan is smaller than Mars, which means that there is a little less gravity, which means we're going to go a little bit faster. All right? Titan is also the only place with such a thick atmosphere that it might be a good idea to hang our roller coaster from hot air balloons. So that's what you're going to see now. We're going to click into the track here. And again, if you get dizzy at any point in time, you're going to close your eyes or look at your toes, and I'll let you know it's safe to see them again.
Oh my God, so scary!
Again, feel free to
I'm
stretch
so
your hands in the air,
scared!
but make sure we use our
I'm
wings
so
side.
scared! I'm afraid of heights, but I'm okay because I'm not actually high.
You're not high? So when you go on stuff, you're high?
Yeah.
What drugs do you take?
That's scary! Look at the sky.
What the fuck?
Is this better, Weston?
Bro, you actually got scared of the roller coasters?
No.
I was about to say, bro.
I'm just scared of heights.
I've been recording for 8 minutes now.
Didn't you say that this was going to be 30?
Alright, well then I'm recording for that long.
I was going to post a 30-minute. Oh! What? Did it just glitch?
No, we're upside down. I think. No, we're not.
This looks like fun.
Not really. It's so CGI.
All right, if you had to close your eyes, you can open them back up again. Welcome back to
Fuck
Saturn.
up in
And we're actually
Saturn.
going to reset our rocket ship so we can see that solar system one more
fuck?
time. Here we go. Okay, so again, we said to the center was going to be the sun, and then we had our 4 rocky inner planets. After Mars, this is where our asteroid belt hangs out. Then we've got Jupiter, Saturn, Uranus, and Neptune. Beyond Neptune is where the Kuiper belt is, and that's where Pluto hangs out. Now, is this everything in our solar system? Absolutely not. And in fact, to see everything, we are going to have to back up a bit more. We're going to go to the very edge of our solar system, and to get there from the Earth in a rocket ship would take about 300 years. This is what's known as the Oort cloud. The Oort cloud is an area of space at the very edge of our solar system where millions of icy chunks hang out. If any of these icy chunks get pulled into the center of the solar system, they become comets as they melt and as they get closer to the sun. To get to the outer edge of the Oort cloud would take us about 30,000 years. So it is quite the trip. But once we get through the Oort cloud, we can see the stars again. And as we look at the stars of our constellations, you might notice that some of them are actually shifting. And that is because these stars, well, they are not solid. They're not in one spot. We're going to fly through the constellation of Orion now, and we're going to check out a spot in his constellation that is not a single star. Although from our spot on the Earth, sometimes it does look like a single star if you're just looking with your eyes. If you use a telescope, or as you can see we've flown here, we can see this. This is a cloud of gas and dust in outer space. This cloud of gas and dust is called a nebula. And because it's inside of the constellation of Orion, we call it the Orion Nebula. This is one of the most active star-forming regions in outer space that's near the Earth. So lots and lots of new stars are being created here. And because that is the case, scientists like studying this particular nebula when they want to learn more about how stars form. Now, by studying these nebulas, we've found that stars form when you have a cloud of gas and dust, and that gas and dust starts to draw itself together. It starts to collapse. And as it does, more and more gas and dust is pulled in towards the center. That makes it spin and starts it to heat up. Eventually, so much stuff gets pulled into the center that an explosion happens. That is when the star starts shining. It starts giving off light and energy, and there's still some dust around it. Now, eventually it blows most of that dust away, but before it can do that, we can see planets forming, or asteroids, or comets. So all the things that we find in our solar system would have formed at the same time as our sun, which is pretty interesting. So our sun did form in this manner, it just didn't form in the Orion Nebula. We formed in a different nebula that has since been blown away. Now this is a really good example of stellar birth, of stars being created, but let's go check out an example of what happens when a ginormous star dies. We're talking a star that is more than 15 times the size of our sun. To find this example, we're going to fly to the very center of our galaxy. What's our galaxy's name, by the way? Milky Way, okay. So, when scientists first looked at the center of the Milky Way, all they saw was this, a bunch of stars. But these stars were behaving weird, because if we look at the very center of these stars, we notice they're all orbiting this one little spot in space. But we don't see anything there. There's got to be a lot of gravity in that one spot. What do we think could be there? A black hole, absolutely. And as technology's gotten better, we have not only been able to determine that it's a black hole, but we've been able to see it. So this is called Sagittarius A star. It's the supermassive black hole at the center of our galaxy. That dark spot there is the singularity. If you get too close to the singularity, you will be sucked inside, but not before being stretched out into a thin spaghetti-like strand of matter. That effect, by the way, is called spaghettification. The stuff you can see swirling all around is the accretion disk. This is where stuff starts being pulled into the black hole. Once you get to this edge here where the black starts, that is the event horizon. Once you cross the event horizon, you can't escape, not even light can escape. However, sometimes this material spinning around the black hole gets sped up so much, it gets ejected away from the black hole, and we see that as X-rays. Some black holes are the strongest sources of X-rays in our night sky. Now, a lot of people get a little scared when we start talking about black holes. They think that the Earth is going to disappear inside of it, and I just want to make everybody feel a little bit safe. So, we're going to back up, and we're going to check out where the black hole is versus where the Earth is. So if we fly outside of our Milky Way so we can take a look at it, we'll see that the black hole at the center of the Milky Way is right about here, in the center of our bar and spiral galaxy. So it's right at the center of the bar. And the Milky Way, sorry, not the Milky Way, the Earth is right over here in the Milky Way. These are all the stars of our constellations. We're right at the center there. So when we see the constellations, we're not seeing stars from the entire Milky Way. We're only seeing the stars in the Orion arm of our Milky Way. Now, the way we look out into space is actually affected by the shape of our galaxy, because our galaxy is not only a bar and spiral galaxy, it's also a bit pancake-shaped. It is rounded and flat on the top and bottom, but it has a pretty thin edge, which we're going to see here. So if we look through the edge of our galaxy, we don't see very much because there's a lot of stars and gas and dust in the way. But if we try to look through the top or the bottom, then we're able to see a lot more. So that does affect the way we see the rest of the universe. Now, is the Milky Way the only galaxy out there? No. Absolutely not. You guys are totally correct. Let's back up and check out the local group. The local group are the galaxies that are closest to the Milky Way. They're all gravitationally attracted to each other, so they're staying in the same area. Our closest neighbor is the Andromeda Galaxy right there. Andromeda is visible in our fall evening skies, so you can actually see it with just your eyes. I'm about to give you guys your first photo opportunity of our show. This is a picture of the Andromeda as taken by the Hubble Space Telescope. So this is a real image of what our closest neighbor looks like. We can see that Andromeda is also a spiral galaxy. We can also see it's a lot bigger than the Milky Way is. The Milky Way has about 200 billion stars inside of it, and Andromeda has about 2 trillion with a T. So it is much, much bigger than the Milky Way. And it's also heading directly for us. The Andromeda and the Milky Way galaxy are headed on a collision course, and in a couple of million years, we are going to crash into the Andromeda galaxy. But don't worry, the Earth should survive, and that's because all the stars and the planets are basically going to slingshot past each other and have a lot of near misses. So we shouldn't be affected. What we'll see instead happen are the constellations being pulled apart as the stars are distorted, their places are changed, and we'll see new stars being formed as the clouds of gas and dust create new stars as they smash into each other. That is the only thing that's going to smash, are those nebulas in space. Now, is our local group of galaxies it? Are these all the galaxies in the universe? You guys are correct again. We're going to fly out, and this is probably the prettiest thing you're going to see today, because these are all the bright galaxies. Every single dot you see is, in fact, a galaxy. So we could be talking about collections of millions or collections of trillions of stars. And they are all accurately placed based on our observations from here on Earth. And even still, this is not everything. If we want to see everything, we have to back up to the very edge. Every dot you see again is a galaxy. The dark patches at the bottom and the top of this image are just because of the way our galaxy is shaped. Remember, we can see easily through the sides, but not through the top and bottom, the edge of our galaxy. We think there are lots of galaxies in those patches. We're just not able to see them through the Milky Way at this point. And again, every single dot you see is accurately placed to different surveys that we've taken of our night sky. The only other thing we can see here at the edge of the universe is called the cosmic microwave background, the CMB, and that's what you're seeing at the edge of everything. This is the shock wave of the Big Bang. Light has not traveled beyond this yet, so we don't know what's beyond it. We don't know if there's an edge to anything, or if we can continue to travel further out into space forever. One day, we hope that our equipment, our technology, will get so much better that we're able to detect things that are further and further away from us, possibly all the way at the edge of the cosmic microwave background. But for now, this is it. This is everything we can see. And so just like a real trip on Earth, I'm not going to leave you here at the edge of everything. We are going to make that return trip to the Earth. And so we'll fly back past all those galaxies, back into the Milky Way, and past the stars of our constellations. Through the Oort cloud, past the outer planets, all the way back home towards the Earth. And as we come to land back on the Earth, I just want to remind you, as our technology has gotten better, we've been able to see further and further into space. If this is how far we can see now, imagine what we'll be able to do in the future. And so with that, we come to the very end of our journey through space.